And we're excited to keep moving now with our session on hands-on mathematics. Excuse me, I didn't finish that. Hands-on mathematics. In the chat, I just shared a link that will take you to the graphic organizer that Khalilah is going to share during her presentation. So once again, I just put in the chat the link for the race graphic organizer that Khalilah is going to talk about during her presentation, so you can access it just by clicking on that link. And at this time, I'm going to turn it over to the phenomenal Khalilah Campfield. Don't forget to unmute yourself, my dear. I tell you, she is a mathematics guru. You just get ready for an energetic, wonderful presentation. All right, Khalilah, it's all you.
Oh, yes, I'm excited. Yes, I know everybody's thinking not math somebody could be that excited about, but I'm always excited about math. Yes. Thank you, Dr. Williams. I'm trying to get this off my, there we go. Thank you, Dr. Williams, for that good intro. Yes, you know, I always am excited about math. So let's get hands-on mathematics started. Can everybody see my screen? I know you can. Thank you.
Yes, ma'am. We can see it. Thank you so much.
Okay, I tried to put on my contacts. I couldn't. All right, so let me tell you a little bit about me. I am Khalilah Campfield. I have been an educator since 2005. I left my corporate job as an engineer and an accountant with Caterpillar to become a math teacher, because what I realized was people just didn't like math, and I felt like I needed to get them to like it so I could have fun at work as an engineer, and I just never went back. I've been an educator for the past 15 years. I've been a math teacher. I've been a math coach. I've coached teachers. I've helped open charter schools. Now I currently am the head of school at a small alternative school here in Atlanta, well, out in Forest Park, Georgia, okay? And that's a lot about me. That's good. I can't, there we go. So now, Marzano's research on high-yield strategies puts non-linguistic representation on the map. Since his 2001 publication, Classroom Instruction at Works, teachers have increased their use of graphic organizers, movement, 3D models, mental images, and manipulatives in the classroom, things that just help math work. Not just math, any classroom, but definitely in math. 3D models work, graphic organizers, anything that you can get them to moving. It just combines all the essential tools that are needed for your classroom. So this book right here, is anybody familiar with this book right here? Can you kind of put it in the chat? Maybe somebody has blessed you with it. Somebody has told you about it, maybe. Dr. Williams, anybody saying anything? It's just a good one to have. So if you don't,
absolutely. Angelique Smith says she loves this resource, Khalilah.
See?
Marlon Pilson and Samantha both said yes, they are aware, and I have to throw my 2 cents in. I love this book. Very practical strategies. Yes. I love Marzano.
You gotta love them. You gotta love them. See, I thought it was just me. I thought I had all the golden tools for myself, but it's okay.
Oh, and wait a minute, Demetrius said, yes, I have that book and a few more of Marzano's books. So yes, we are in good company this morning, Khalilah.
Love it. Do you see me doing, as long as everybody can see me doing my happy dance, because I love it when everybody has good tools to use. That means that everybody will have great classrooms. You understand? When you have good tools, that means you have what you need to put on your good show in your classroom. All right, so I am here to talk about race. Race is a graphic organizer that is used in ELA. It's a writing strategy that helps students to remember to restate the question, answer the question, cite evidence, and explain their evidence. This is something that they use in ELA, some people, English language arts, because some people just don't, they just might not be familiar. But I want you to know something. Just because it's a tool that is used in ELA, it is also perfect to use for mathematics, okay? Because what's good for ELA is also good for mathematics in this case, all right? We're gonna, it helps students to, it's a graphic organizer, and it helps the students to rewrite constructed responses, respond to constructed response questions in math, all right? I'm getting a little nervous, I don't know why, but let me get it together, okay? I think it's because I just stepped on my glasses. So rewrite the question requires students to translate the word problem to a numerical expression. It allows teachers to assess if the students know how to convert from math terms to appropriate operations and algorithms. So simply here, they're going to rewrite the question. Answer the questions. This requires the students to assess manipulatives or models to represent the math, or assess key concepts, skills, and formulas to make the necessary calculations. It allows teachers to assess if they know how to go from math terms to appropriate operations and algorithms. I'm on the wrong, sorry. I'm really just, Rita, give me a second. Get it together. All right. So it allows teachers to assess, and I know allows teachers to assess if they can follow mathematically sound procedures to model and meet the calculations. It's the notes. When it comes time to checking the answer, you allow the students to either use another method, concrete, representational, or abstract, CRA, which a lot of us are familiar with, than the one used to answer the question. There's always more than one way to skin a cat, so you always want to make sure that you are continually making them critical thinkers with this strategy. So if they can solve it one way, you want them to check their answer another way. And then they also evaluate the calculations that led to their answer to make sure they're correct, to make sure they're accurate. It checks the reasonability of the solutions, so it allows them to think. Explain the answer. It requires the students to clearly communicate mathematics that justifies their solutions. It allows the teacher to also assess if the students can provide a concrete and logical rationale for their solution. So why did you come up with this answer? How did you come up with this answer? Does it make sense? And remember, if somebody is able to explain to you what they did in a manner that you can understand what they did, follow their steps, maybe even see if there are some corrections that need to be made, or ask them, well, why did you do this? I could have done it a different way. If you're able to have that conversation when you're explaining the answer, it's always a good thing in math. Now ponder this. From what I've told you about race so far, would you friend this strategy or would you block it? Can you put it in the chat for me? Me, I would friend it, especially as a math teacher, because it helps me with my students. So Dr. Williams, okay, there we go. I see some chats popping up.
All right.
Are you reading? Oh, hold
on. Yeah, we're giving them a moment.
Okay. I tried
All
to
right. Reese said she would best friend this strategy. Demetrius also said BFF. All right. Kiera, friend it. Trevor said, as a math teacher, I too would friend it. All right. All right. Marla and Sonia said they would friend it. Sarah Danielle said that she has actually taught a similar strategy through her student teaching with interactive flip books and guided notes. Oh, I love it. I love it, Sarah Danielle.
I like that.
And we share the same middle name, Sarah. Anna Weaver said friend it, and so did Novelette. All right. So we're moving forward with race.
So everybody, so we're friends on Facebook now. Oh, everybody loves Dr. McStuffins, don't we? So we're going to use Dr. McStuffins to help model race. If race, the standards focus on fluently adding and subtracting using strategies and algorithms based on place values and properties of operations. I will model using Dr. McStuffins this race strategy for you. Okay. Last week, Dr. McStuffins treated 154 stuffed animals. This week, she treated 256. How many more stuffed animals did she treat this week? The numerical expression represented is 256 minus 154. So we rewrite the question. Trying to make sure I have a few math teachers on here, so I'm making sure it's processing. I know sometimes this is the elementary one, so it's kind of like, boom, we get it. Dr. McStuffins had 154 stuffed animals. She treated 154. This week, 256. How many more? Subtraction. So now, that's how mine work. So we rewrote the question.
I love it. So when we rewrite the question, we are taking the verbiage, we're taking the words, and we're rewriting, and we're making sure that we are writing the numerical expression that reflects the words. I love it. Khalilah, I also want to interject that we have educators from across the country who have joined us. And so we want to make the point that the standards that you're focusing on are from Georgia. So these are the Georgia standards of excellence. So I put that in the chat. Because I'm so glad that we have persons from North Carolina, Texas, just some of everywhere.
So so yes. So let that be noted. These are Georgia standards of excellence. I like that. So let's go. So you with me? That's the first step of the race strategy. Rewrite the question. Next one, answer the question. Race provides the opportunity for students to solve problems using multiple strategies. To answer the question, I'm going to use these value blocks. Anybody? I like my chat because I like interaction. So is anybody familiar with the value blocks? I know we had a few math teachers. You can just say yes, nah, I'm not really familiar, but I'm gonna keep it moving. I just kind of just want to see.
Yes, place value blocks. They are so wonderful. Place value blocks.
That's what they're saying in the chat?
Yes, they love place value blocks. Everybody is familiar with them. We know that place value is a difficult strategy in elementary school, so they use those place value blocks.
Yes, so we represented 256 with 2 flats, 5 rods, and 6 units. Is everybody? Yes, I know. And we need to subtract by 154. So in my mind, that's what I see. I need to take away a flat. I can take away the 50 and take away 4 units. Well, 5 rods, 4 units, and that's 154. And so what does that leave me with? It should leave me with how many more stuffed animals she treated this week, which is 1 flat and 2 units. She treated 102 more stuffed animals. Students should write their answers in complete sentences. This helps them communicate exactly what they were solving for in the correct units of measurements. Does this make sense? Of course it does. So now we're still on the second step. So we've rewritten the question. Now we've answered the question, and we've also used the manipulatives. So now let's do my favorite part. Let's check the answer. We have to make sure it makes sense. So I'm going to go back a screen. If you look, we answered the question using the place value blocks that we love so much. And to check our answer, we are going to try an alternative method. We're going to use this one. We like to have multiple representations of the algorithms. And so we are, in this case, I must point out, having students use multiple representations helps develop them as the mathematical proficient student described in the standards for mathematical excellence practice. So for this problem, I use the number line to check our answer. Notice I plotted both 256 and 154 on the number line. First, since I am subtracting, I traveled to the left 100 points and landed at 156. No, 100 points.
Yes, you went back 100 and landed
I see it.
at 156.
I see it. And from 256, and I landed at 156. I'm let it read. Second, I move to the left 2 points, and I land on 154. The first 100 points plus the 2 points equal 102. Therefore, this method shows 256 minus 154 is 102. If you're wondering, we could have started at 256 on the number line, then subtracted 154. The answer is yes. Both procedures support the mathematics in this problem. So now the last step of race is explain the answer. Now for this explanation, when I add 102 and 154, I get 256 because 100 plus 100 equals 200, 0 plus 50 equals 50, and 2 plus 4 equals 6. 200 plus 50 plus 6 equals 256. I know you're thinking there is no way a third or fourth grader will produce an answer like this. But if we consistently model how to explain our thinking and post artifacts in the classroom showing our work, third and fourth graders certainly can step up to the plate. The key phrase is consistently model. You have to be consistent. You have to give them things to look at. You have to show them what you want so that way they can output exactly what you put in. We cannot model the process 2 or 3 times and expect them to be able to provide such rationales. We have to do it over and over and over again. We have to work on the skill from the beginning of the year to the very end. K through 12 are sometimes not required to explain their thinking, but we are trying to build critical thinkers for the world. So we have to make sure that they are happy explaining their answers, because if they understand how to answer the questions correctly, they will be happy to answer. If they understand how to answer the questions correctly, they will be happy to participate and explain more and think more and critical think more and just give you more output. We generally do not focus on the explanation, but that is a wonderful opportunity for the conceptual understanding to be practiced by students and assessed by teachers. So explanations gives them a chance to talk. Explanations gives you a chance to assess. Explanations gives you a chance to see what needs to be done. So one word summary. Now that you have seen race modeled, what one word would you use to describe it? Can I get some answers in the chat?
All right, Sonia said that great point. Students need to be able to explain. And while we're waiting on our participants to put their one word in the chat that describes race, we want to reiterate the point that this is a process that has to be modeled and modeled consistently. I like the fact that when you were going over the problem with Dr. McStuffins, you focused on 2 different methods to solve the problem. First, we use place value blocks, and then we proved the answer that we used, or proved the answer that we got using place value box with the number line. And so,
and those are ways to catch different learners. That's what I like about the showing 2 different ways, because you can still engage different learners of your classroom. So where I might have just understood the number line way, now that I might be seeing it done in the classroom, I can understand the place value blocks. Now I get a better understanding.
Right, and so we're looking at the standards for mathematical practices. They also talk about the fact that in order to build mathematically proficient students, students need to be able to solve problems in multiple ways. And so using different methods That definitely helps us to build stronger math students, because we don't want them to just follow the algorithms, the standard algorithms. We want them to be able to find the answers in different ways. So Demetrius said strategic, race is strategic. Frederick said detailed, Trevor, procedural. Reese, useful. Anna, helpful. Monica, justified. Marlon, application. Monica came back and said, yes, race causes us to make sure that justification is there. So perfect. We rewrite the question, we answer the question, and then we increase that Bloom's taxonomy by having them check their answer and then explain their answer. And Stephanie said, race is memorable. I love it. I love it. All right, Khalilah, back to you.
Okay, memorable enough. I like that. Memorable enough so that way when they're breaking down word problems, you know how students hate word problems. This is a strategy that can help them break them down so that way they feel comfortable tackling them. So can race be used in kindergarten? Let us know what you think. I know I told y'all I like interaction. So Dr. Williams, you got a poll for me? No?
I do. I just have to launch it. If you give me a
okay. No problem. So let me know what you think. This strategy that we were using, that we just used, and I kind of did a simple problem. Can race be used in kindergarten? It's coming. Just be a little.
Yes, just ponder your thought. Think about it. Think about your standards. Think about where the students are.
In kindergarten.
Just think about, yes, do you think that race can be used? All right. And we are getting ready to launch the poll.
So can you get some 5-year-olds to 6-year-olds to rewrite a question, answer it, check their answer, and then explain it?
All right, the poll has been launched. Can race be used in kindergarten? Yes, no? To be honest, I don't know. It looks like the yeses are there. I'm seeing Stephanie already said in the chat, we use it in our school, in our kindergartners. We use it in our school with our kindergartners and first graders. Awesome, Stephanie. You all are already setting a strong foundation.
Is Stephanie in Georgia? If you don't mind me asking, because you said it.
Stephanie, would you mind? Oh, no, Stephanie is in North Carolina, Khalilah.
Okay.
Perfect, perfect. So 92% of our participants say that race can be used in kindergarten, and only 8% said that they don't know.
They weren't sure. Okay.
All
well, all right. Well, race can definitely be used with learners as young as kindergarten. Here's an example with standard KOA2, which solves addition and subtraction word problems and add and subtract within 10. So on Monday, Clifford had 2 bones on Monday. On Tuesday, he found 4 more bones. How many bones does he have in all? So the first step of race is to do what? Rewrite the questions. The students should write 2 + 4. Of course, I'm going to give some prompting. So of course, that makes sense for kindergartners, because we will go back over the question. On Monday, Clifford had 2 bones. How many bones did Clifford have? 2. On Tuesday, he found 4 more bones. How many bones did he find on Tuesday? 4. And how many bones does he have in all? So in all means what operation? Or what should we do? Is he taking them away? So that's like the type of prompting. Are we putting them together? That's the type of prompting you would do. And I'm all extra with the kindergartners because you want them to get involved. You want them to talk to you when they're rewriting the question so they will understand how you got from here to here. When it comes to answering the question, please do not stop students in lower grades from counting on their fingers. I teach high school. I don't stop the high schoolers from counting on their fingers because sometimes some of them need it. Fingers are great manipulatives that are always with them. Remember that, all right? By putting up 2 fingers on one hand and 4 fingers on the other hand, the students counted a total of 6 fingers, which represented, students held up 2 fingers on one hand and 4, which represented 6. And that's how many bones he would have in all. So 4 and then 2, which gives us 6. And you know, kindergartners just love all of that moving around. So they'll love it. And they'll definitely understand. When we answer the question, just saying 6, we should have them say 6 bones in all. So let's check our answer. Kindergartners can solve problems using multiple methods as well. To check the answer, the student drew pictures of 2 bones and then 4 bones and then counted a total of what? 6. So pictures are definitely something good to use with kindergartners to check the answer. Now let's explain the answer. They'll say simply, I drew 2 bones and 4 bones and got 6 bones. Or they can say so many different things, but this was just the explanation to our answer, just so you'll know this can work for the kindergarten level. So what strategies were put in place to make the process accessible for the kindergartners? In the chat, let me know. Anybody? I know one thing was the teacher reads the word problem. Anybody else? I kind of worked through it.
Yeah, they're responding.
I know that it's slow motion.
Trevor said at his school, they use race for ELA in kindergarten, so he doesn't see why there's any reason that it shouldn't be used in math as well. So as you started off saying, race started off as a strategy in ELA to help with constructive responses. So Trevor said their kindergartners are using race and ELA, so he's saying they definitely should be able to do so in math as well.
Is he in Georgia?
That Demetrius, yes, he's in Georgia. Demetrius said that she saw that the modeling was put in place to help with the kindergartners, help with the scaffolding of kindergartners implementing race. Stephanie said manipulatives, and Reese said the use of fingers. So, all right.
The manipulatives. Okay, we with you. Are the people responding math teachers? That's the other thing I wanted to know, or ELA.
So I think with elementary teachers, a lot of times they teach multiple subjects. So we have some that may be departmentalized.
Okay, so some of them, okay, no problem.
So Demetrius did say that she teaches math. Reese says she teaches all subjects. Stephanie said math and Quest. I remember Quest.
Okay, so let's move on from here. Let's move to race in middle school. By looking at the 7th grade standard that includes applying properties of operations as strategies to add and subtract linear expressions with rational coefficients. Carson went to Chick-fil-A 2 times in December, 1 time in January, and 2 times in February. She spent $20. If she put in the same order each time, how much did she spend on each order? It is vital for students to state what the variables represent, all right? So that's why we let X equal the cost of each order in this problem, all right? One way the problem can be rewritten is if 2x plus x plus 2x is equal to 20. What is x? Another way is, of course, my math teachers are like, oh, another way is 2x plus x plus 2x, which is 5x. So another way is 5x is equal to 20. But we still want to know what is x. So we've rewritten the question. Now let's answer the question. Although the answer is quite obvious, we are still going to have students represent their thinking using multiple representations. Let's use algebra tiles to answer this. Each green rectangle represents the positive variable, so we add 5 green rectangles. Yeah. Am I going backwards? No. There we go. Each yellow square represents positive 1. So we added 20 yellow tiles. For this particular problem, the tiles can be distributed in a way that each variable has the same amount of tiles on each row or the other side on the other side of the equal sign. So you see how it's evenly distributed? Sorry, excuse me, I lost my place real fast. There we go. Since the tiles were evenly distributed amongst each variable, we see x is equal to 4. So that means each order she spent $4. And I'm pointing to my screen. So each order was $4. To check the answer, we are going to solve the equation algebraically. This is one of my favorite ways, using the properties of operations, and hope we get the same answer. So let's see. If x is the cost of each order, we have 2x plus 2x is equal to 20. We know that gives us 5x is equal to 20. Divide by 5, and x is equal to 4. Not just 4, but $4, the amount she spent on each order. So that's us checking, and guess what? We got the same answer. So now let's explain the answer. This is the part that's always a little hard for the students, but it's always worth it. Guide them through it. We use the concept of multiplication as repeated addition to explain our answer. Again, even in middle school, we have to model how to justify answers. This does not come naturally to students, and truth be told, it doesn't come naturally to adults either. So 4 makes sense because 4 plus 4 plus 4 plus 4 is the same as 4 times 5, which gives us 20. Now, these are my little, good little, I guess these are some teacher nuggets. For those of y'all that, I'm pretty sure, because this is a dope class and we have great teachers on here, but these are some places where you can find some free, and we all love free, online manipulatives, and especially in the elementary classroom with the fraction strips and the place value blocks. The algebra tiles are more so for the middle schoolers, but these are great free sites. I definitely don't have stock invested in them, but I probably should, because they're great tools. And I noticed once I discovered them, thanks to Dr. Williams, I started using them more. So if you would take the time, maybe you want to screenshot it, I'm not sure, but I will give you a quick minute to screenshot. These true nuggets. So now I'm gonna move on. So now this standard right here is in Algebra 1 and Analytic Geometry. It focuses on solving quadratic equations in one variable. So now we've taken the race strategy where to high school. So let's do it. One weekend, as Beyonce and Jay-Z are cruising on their yacht, a storm arises. A rescue helicopter hovering 64 feet above their yacht drops a harness attached to a rope. The height and feet of the harness above the yacht can be modeled by H of T is equal to 16T squared plus 64, where T is the time in seconds after it is dropped. After the harness drops, how many seconds will it take to reach the yacht? Fun fact, the yacht pictured was or is still owned by Beyonce and Jay-Z. It's a problems like this draw your students in also, because who doesn't love Bay and Jay? Let's just keep it real. Just from, think about it, all of these type of problems, we've drawn from Dr. McStuffins, you're going to get all your students' attention. So they're going to want to use this race strategy just based off the problems that you're using. So make sure you keep it interesting. And I know that was our first speaker. He talked about that. Make things relevant to your students. So you see, all of these nuggets are actually all combined.
You have 3 minutes.
Oh. Okay, I can get through high school. That's no problem. 3 minutes. I'm a quick talker. As stated in the problem, T is time in seconds after the harness is dropped. If 0 is equal to negative 16 T squared plus 64, what is T? Let's answer the question. I got 3 minutes. I'm going to make it work. To answer the question, we are going to algebraically solve the quadratic equation. I can add 16 squared to both sides. Boom. That's my favorite. And because, okay, I need to move the picture. There we go. And because 16T squared is equal to 64, what's my next step? I can divide both sides by 16. Once I divide both sides by 16, T squared is equal to 4. Students love when you get to this if they remember this, because I can take the square root of both sides, because the square root and the squared cancel out. And so once I do that, I have T is equal to plus or minus 2.
Khalilah, I apologize. You actually have 11 minutes. I'm sorry.
It's okay. It's okay. I was about to start speeding it up, but now I can slow it down. That's okay, Dr. Williams. I know you know. So now let's answer the question. Since the measurement for time cannot be negative, T only equals 2. Does that should make sense to everybody, especially my math people. The harness will reach the yacht in what? 2 seconds. So now let's check our answer. Here's another little nugget. To check the answer, we are going to graphically solve the equation by inputting it into the online graphing calculator on Desmo site. My students use this, so this is definitely a good site. The website is given on the slide. And once we put it in, you'll see the parabola intersects the horizontal axis, which is the t-axis in this problem. So at t is equal to -2 and t is equal to 2, we already eliminated the -2 as an answer since we cannot have negative time. Therefore, our graph backs up our algebraic answer, which makes sense. Once again, if you need to screenshot this little Desmos calculator, I'm pretty sure y'all are all great teachers. So if you need to use it on the high school level, definitely use it, because it works, because we all don't have calculators. And now let's explain the answer. Please note, high school students also need you to model how to justify the answer. They're the laziest in high school. So you have to model, you have to continue to make them, because they will give you the shortest explanation. But please make sure you model. Okay, so although quadratic equations often have 2 answers, it makes sense this one only has 1. Before the harness is dropped, it is 64 feet above the yacht. The only time the harness will be 0 feet above the yacht is when it lands after being dropped. I thought that was a great explanation. So another question that comes up is, if we do not have manipulatives, can we still use race? Can you tell me in the chat what you think real quick? If you do not have manipulatives, can you still use race? I just need one person to tell me, really. Anybody in the chat yet, Rita? Dr. Williams?
Everybody's saying yes. We even
Oh,
got
okay.
Absolutely. All right.
Yeah. Oh, I think you threw the absolutely in there. Yes, 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 absolutely, yes. Race is a strategy that, even though we love the manipulatives because it helps with the different types of learners that we have in our classroom, you can still utilize it if you don't. All right. So let's try one. Of course, J-Lo. This should have been me. Let me go back to my problem. All right, J-Lo practices 95 minutes a day. How many minutes will she practice in 12 days? This is reflecting on a 4th and 5th grade standard on multiplying and dividing strategies, okay? So 95 minutes a day. How many minutes will she practice in 12 days? And I think she recently turned 50, so I need to step my practicing up. So let's rewrite the question. The problem represented will give us 95 times 12. Makes sense. 95 minutes a day, 12 days, makes sense. Now let's answer the question. J-Lo practices 95 minutes a day. How many minutes will she practice in 12 days? We use decomposition to break down 95 times 12 down to smaller problems. We use colors to help everyone understand from where each number came. So let's look at it. 95 is equal to 90 plus 5. And so we end up with 90 times 12, which gives us 1080. 5 times 12, which gives us 60. And then we add 1080 plus 60, and it gives us 1,140 minutes. So J-Lo practiced 1,140 minutes in 12 days. So now let's check our answer. We want to make sure it makes sense. I feel like I have my clicker. So now to check the answer, as done previously, we use a different method, multiplication as repeated addition. So 95 plus 95, 95 plus 95, 12 times, because I'm not going to say 95 plus 95 plus 95. I was. Thankfully, we calculated the same solution. 1,140 minutes. And it may seem like a lot, but some students actually work them out just like this. So it makes sense to show different ways. Because like I said, I always say in my classroom, there's more than one way to skin a cat. So let them skin them cats. And now let's explain the answer. Finally, here's the explanation. So in elementary and middle school, although we encourage the infusion of manipulatives while students use race, that infusion is not required. Students can still use alternate methods of solving to strengthen their conceptual knowledge. So since 100 times 12 is 1,200, it makes sense that 95 times 12 is 1,140, which is a little less than 1,200. That's how I saw it. Make sense? So race can still be used without manipulatives. I think. Now, 4 corners. Which corner represents how you feel about? This concludes the modeling of how race can be used in our classroom, okay? To wrap up this session, we want to know which corner represents how you feel about implementing race and multiple methods of solving in your classroom. In the chat, I need you to tell me why you're in which corner. And I also want to make note of the this 4-corner activity. If you have to teach virtually, and maybe if you have different levels, you can use this also during Zoom. All right. So first, let me show you the 4 corners. Corner Killmonger, you still don't fully understand what everything is all about, and you may be focused on the wrong things, just like in Black Panther. So anybody in corner number 1, you still don't fully understand, or you want to wait until I show you all the corners? I think I'm gonna leave corner Killmonger alone. Corner Wakabi, you consistently need the support of a strong educator to help you see your way through. The next corner. Corner Mbaku, you might need some guidance, but eventually you will be able to implement it when it counts. Implement race and multiple representations in your classroom like a champ. And then corner T'Challa, you are able to fully implement the strategies right now. Oh, so in the chat, let us know where you are at. Go, let me know which one you are at. If you're in corner number 4, corner number 3, corner number 2, corner number 1.
Let's go to the next slide, because I think the last slide has all 4.
Oh, I see it.
All right, so I see Frederick said corner number 3, Mbaku. All right, he can pull it out. T'Challa, Trevor is ready to go ahead and implement. Anna, Anna is there with Frederick in corner number 3. Reese is there in corner number 3 with Mbaku. All right, that's a good place to be. That's a good place to be.
I just like corner number 1, but I'm in corner number 4 myself. But I like corner number 1.
All right, so we have some that say we might need some more guidance in number 3, but eventually they'll be able to implement it. And I had to throw a note in the chat. Thank God for our instructional coaches and for those mentor teachers and those strong teachers in our building who we can collaborate with in order to implement various strategies. So Victor and Lamont, Kiera as well, Navalette, corner number 3. Demetrius, all right, we have a corner number 4. Another number 4, so we have some T'Challas in the house. Pete Williams said corner number 2, he would consistently need the support of a strong educator. And again, there's nothing wrong with that. We have our persons in the building who are there to coach us. Marlon Pilson said corner number 4. So we have a nice array. And it's interesting that we don't have any still in corner number 1. So
I am, because I like corner Killmonger, just personally, but
right, we're talking about our practices. We don't have any in corner number 1. So I know you want to be in there with Killmonger for who he is, but nobody is in corner number 1. So thank you for sharing this strategy. Back to you, Khalilah.
All right. All right, so now please post one nugget you learned from this session on your Facebook page with the hashtag Nuggets for New Teachers and make the post shareable. Remember, we are going to select several posts to share on our page. If your post is selected, you will receive an Amazon gift card for your classroom. Not for personal use, for your classroom.
But of course, we won't be watching. And so we've already had 2 winners. Trevor, you should have received your Amazon gift card, as well as Reese. Those were emailed to you. Khalilah, thank you so much for talking to us about race. As was shared earlier, we have educators that are using different formats of this strategy. But I like the fact that you really focused on having the students use multiple representations. We're not just using the standard algorithm all the way through. When we answer the question, we want to use one method, whether it's place value blocks, number line, whether we're doing solving something algebraically or graphically. We're using one method when we answer the question, and then we're going to use a separate method when we check our answer. So that's what fine-tune does to really separate our use of race from others. We are making sure that we're not just focusing on the standard algorithm. We're not focusing on the way that we learned mathematics when we were in school. Not talking about you millennials, or those of us who have been here for a little bit longer.
And
we want to make sure
all learners. So that's what
we want to make.
How you do it.
We want to make sure that we're using multiple representations so that we're building students who are mathematically proficient according to the standards for mathematical practice that the Common Core told us that everyone across the nation needs to be able to build. So thank you so much. Rewrite the question, answer the question, check the answer, and then E, explain the answer. We have to be honest. We normally do not require students to explain their answers. And so that's something that we're going to have to model. We're going to have to pull out those charts, those Post-it notes, and we're going to have to model how to explain the answer. And guess what? We have to leave those artifacts up so we can continuously refer back to them and allow our students to use them as exemplars. So as Khalilah said, we're not going to think that our students are going to be able to do any of this just when we introduce it to them or after the second try. We're going to build mathematically proficient students. We're going to continue to bring it back around and make sure that they're strengthened. Thank you, Khalilah. You can go ahead and stop sharing your screen now. We appreciate your talking to us about hands-on mathematics.